A single tablespoon of material from a black hole weighs more than Mount Everest. These cosmic titans represent the ultimate triumph of gravity over all other forces in nature. Nothing that crosses their boundary, not even light itself, can ever escape. For decades, black holes existed only in the mathematics of Einstein's equations, dismissed by many scientists as impossible curiosities. Today we know they're not just real, they're everywhere. Millions of them drift through our galaxy alone, invisible hunters waiting in the darkness. The supermassive black hole at the center of our Milky Way contains the mass of 4 million suns compressed into a region smaller than our solar system. What you're about to discover will transform how you understand the fabric of reality itself. The event horizon represents the ultimate boundary in our universe. This invisible sphere marks the point where escape velocity exceeds the speed of light. Cross this line, and your fate is sealed. Physics itself guarantees your destruction. The size of an event horizon depends entirely on mass. A black hole with Earth's mass would have an event horizon just 9 millimeters across. The supermassive giant at our galaxy's center has an event horizon 17 times larger than our Sun. But here's what makes this boundary truly strange. From the outside, you'd never see anything cross it. Time dilation near the event horizon becomes so extreme that infalling objects appear frozen, their light stretching into infinite red wavelengths. Yet from the perspective of something falling in, the crossing happens in finite time. You'd plunge through without even noticing the boundary, continuing your fatal journey toward the singularity at the center. This asymmetry between perspectives reveals the profound weirdness of space-time near these objects. At the heart of virtually every large galaxy lies a supermassive black hole containing millions to billions of solar masses. These aren't just passengers along for the ride, they actively shape their host galaxies. The relationship between a galaxy's central black hole and its overall structure follows precise mathematical laws. A galaxy's bulge mass directly correlates with its central black hole's mass, suggesting they evolved together. When these giants feed, they become quasars, the most luminous sustained objects in the universe. A single quasar can outshine an entire galaxy of 200 billion stars. The energy released by matter spiraling into supermassive black holes generates powerful jets that blast out for millions of light years. These jets regulate star formation across vast distances, preventing galaxies from converting all their gas into stars too quickly. Without supermassive black holes, galaxies as we know them couldn't exist. The very structure of cosmic evolution depends on these central engines of destruction and creation. Stellar mass black holes form from the deaths of massive stars. When a star more than 20 times our Sun's mass exhausts its nuclear fuel, no force can prevent gravitational collapse. The core implodes in less than a second, reaching densities where atomic structure itself disintegrates. Protons and electrons merge into neutrons, and if the mass exceeds about 3 solar masses, even neutron degeneracy pressure fails. The collapse continues past the point of no return, creating a black hole. The outer layers rebound in a supernova explosion, visible across billions of light years. Remarkably, these violent deaths seed space with heavy elements necessary for planets and life. Every atom of carbon, oxygen, and iron in your body was forged in stellar furnaces and scattered by these cosmic catastrophes. Recent discoveries reveal that black hole mergers, detected through gravitational waves, create elements even supernovae cannot produce. Gold, platinum, and uranium owe their existence to these collisions. Destruction and creation intertwine at the most fundamental level. Black holes don't just warp space, they fundamentally alter the flow of time itself. Einstein's equations reveal that gravity and acceleration are indistinguishable, and both affect time's passage. Near a black hole's event horizon, gravitational time dilation reaches extreme proportions. An observer far from the black hole would see a clock near the event horizon ticking incredibly slowly. At the horizon itself, time appears completely frozen from an external perspective. This isn't an illusion or measurement error. Time genuinely passes at different rates in different gravitational fields. If you could somehow hover just above a supermassive black hole's event horizon for 1 hour, decades or centuries could pass in the outside universe. This effect has been measured with atomic clocks at different altitudes on Earth, confirming Einstein's predictions. The implications are staggering. Black holes represent regions where time and space exchange roles, where the singularity lies not somewhere in space, but somewhere in your inevitable future. For years, black holes remained theoretical constructs, impossible to observe directly. That changed on April 10, 2019, when scientists revealed the first actual image of a black hole's event horizon. The achievement required synchronizing 8 radio telescopes across the planet, creating an Earth-sized virtual telescope. The target was the supermassive black hole in galaxy M87, 55 million light-years away. The image showed exactly what theory predicted: a dark shadow surrounded by a glowing ring of superheated matter. Even more revolutionary, gravitational wave detectors now routinely observe black hole mergers. On September 14, 2015, LIGO detected ripples in spacetime from 2 black holes colliding 1.3 billion years ago. These observations opened an entirely new window on the universe. We can now probe the most violent events in cosmic history, measuring properties of objects that emit no light. The detection revolution continues. Every observation reveals black holes are more common, more diverse, and more crucial to cosmic evolution than anyone imagined. Black holes stand as monuments to gravity's ultimate power, regions where matter, energy, space, and time reach their breaking points. They're not cosmic aberrations, but essential players in the universe's grand story. From regulating galaxy formation to forging the elements of existence, these enigmatic objects connect destruction with creation in ways we're only beginning to understand. The next decade promises even more remarkable discoveries as our detection methods improve. If this blew your mind, subscribe for weekly facts that change how you see the world.